Hi and welcome to John's Maths Book. In this video, we're going to be looking at verifying the solutions to differential equations. If you like the video, then please hit the like button and I'd be delighted and honored if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. Let's suppose we're given a solution to a differential equation. How do we go about verifying that it is in fact a solution to the differential equation? That's what this video is all about, and I'll be working through some specific examples and demonstrating how to do this. So let's start with a simple example. Let's say we have the differential equation dy by dx is equal to 4y divided by x. And for this differential equation, let's suppose that we're given a solution y is equal to 4x to the power of 4. Let's see how we can verify that this is a solution to the differential equation. To verify this, we need to show that using the solution, the left-hand side of the equation is equal to the right-hand side of the equation. On the left-hand side, we have the derivative of y with respect to x. Our solution is y is equal to 4x to the power of 4. If we now take the derivative of the solution, we get dy by dx is 16x cubed. And this we can substitute into the left-hand side of the equation. On the right-hand side of the differential equation, we have 4y divided by x. As our solution gives us y in terms of x, we can substitute for y, which gives us 4 times 4x to the power of 4 divided by x. If we now expand out the right-hand side and simplify it, we see that it equates to 16x cubed. So as we can see, the left-hand side of the equation is also 16x cubed, thus verifying that y equals 4x to the power of 4 is a solution to this differential equation. Now let's look at the differential equation dy by dx equals y minus x. And let's verify that it has solutions y equals x plus 1 and y equals e to the x plus 1. Let's use the first solution, y equals x plus 1, and prove that the left-hand side of the differential equation is equal to the right-hand side of the differential equation. If we take the left-hand side of the differential equation first, we see that it's the derivative of y with respect to x. So if we take the solution y equals x plus 1 and take the derivative of y with respect to x, we get a value of 1. On the right-hand side of the differential equation, we have y minus x. As our solution is y in terms of x, we can substitute for y. So substituting for y into the differential equation, on the right hand side we get x plus 1 minus x. On the right hand side we have both positive and negative values of x, which will cancel out, leaving a value of 1. So as we can see, on the left hand side we have 1 and on the right hand side we have 1, thus verifying that y equals x plus 1 is a solution to the differential equation dy by dx equals y minus x. Now let's verify that y equals e to the power of x plus 1 is a solution to the differential equation dy by dx equals y minus x. Taking the left-hand side of the differential equation first, we see that it is the derivative of y with respect to x. If we take our solution of y equals e to the x plus 1 and take the derivative of y with respect to x, we get e to the power of x plus 1. So looking at the right-hand side of the differential equation, we have y minus x. Our solution expresses y in terms of x. So our solution being y equals e to the x plus 1. So if we substitute 4y into the differential equation, we get e to the x plus 1 minus x. If we now simplify the right-hand side of the equation, we can see we have a positive and a negative x. So these will cancel and we're left with e to the x plus 1. So the left-hand side we have e to the x plus 1 and the right-hand side we have e to the x plus 1. Thus verifying that y equals e to the x plus 1 is a solution to the differential equation dy by dx equals y minus x. Now let's look at the second order differential equation d2y dx squared minus 2 times dy by dx plus y equals 0, and see if we can verify that y equals x times e to the x is a solution of it. So using the solution y equals x times e to the x, we need to prove that the left-hand side of the differential equation is equal to the right-hand side of the differential equation. As the right-hand side of the differential equation is 0, we just need to prove that everything on the left-hand side of the differential equation using the solution is 0. So to find the first derivative of y equals x times e to the power of x, we need to use the product rule. So the first derivative is x times the derivative of e to the x, which is e to the x, plus e to the x times the derivative of x. So the derivative of x is 1. So the first derivative is x times e to the x plus e to the x. And then if we take the first derivative and differentiate it again, we get the second derivative. So the first derivative is x times e to the x plus e to the x. So the derivative of x times e to the x using the product rule is x times e to the x plus e to the x. And the derivative of e to the x is just e to the x. So the second derivative is x times e to the x plus e to the x plus e to the x. And simplifying this, we get the second derivative to be equal to x times e to the x plus 2 times e to the x. So we can now plug these expressions into the left-hand side of the differential equation. So the second derivative is x times e to the x plus 2e to the x minus 2 times the first derivative, and the first derivative is x times e to the x plus e to the x, plus y, which we know is x times e to the x, as it's our solution. If we expand the bracket out, we then see that the negative 2x e to the x cancels with x times e to the x and x times e to the x, and the 2e to the x cancels with the negative 2e to the x. This leaves us with 0 on the left-hand side equal to 0 on the right-hand side, thus verifying that y equals x times e to the x is a solution to d2y dx squared minus 2 dy dx plus y equals 0.